Hi everyone, welcome back. Following request from several people, especially O-level students, those who are preparing for WAEC West African Examination Council and NECO to solve WAEC Mathematics past questions. God's willing, I'm starting a new series called WAEC Mathematics Made Easy. So in this series, I'll be solving mathematics past questions and be giving hints on how to approach some of the questions in your exam. So it will be in episode, and I will start with the last 5 years question starting from 2021. Do you want to have distinction in your mathematics work? Are you really serious about it? Okay, if you are serious about having distinction in your mathematics, then God has really sent you to the right place. So what are you waiting for? Sit down, take your pen, and follow me up to the last second. But if you haven't subscribed to my channel before, please don't forget to do so. And don't forget to share to your colleagues so that they can also benefit as well. I've made several videos on different aspects of mathematics. I have SSC mathematics from zero to guru for people who want to learn mathematics from scratch. I have this series in Yoruba as well as English language. So your JAMB mathematics series where I solve clearly mathematics past questions in JAMB and UTME. So if you want to obtain 100% in your JAMB, then I implore you to watch that video. So I have many other videos, for example, hard programming in Yoruba, statistics made easy, calculus in 5 minutes, and so on and so forth. Okay, let's start. In this first episode, I'll be solving the first 20 objective questions in the last year WAEC 2021. So in the subsequent episodes, I'll be solving other objective questions as well as the theory. Okay, the first question here today, I think I should just bring it here. So if you have past questions here with you, you can be following me. So the first question here asks us to correct 0.0007985 to 3 significant figure. Yeah, I think I should just put it here so that you can see it clearly. So the question asks us to correct 0.00785 to 3 significant figures. Before, let me quickly brush this up. What is significant figures? When we say significant figures are non-zero numbers. Non-zero numbers, or you say non-zero figures. When we say non-zero, zero means something that is zero, but non-zero means that is those numbers that are not zeros. So what are those numbers that are not zeros? Those numbers are 1, 2, 3, 4, 5, 6, 7, 8. I hope you understand that. So if you are now dealing with, or you want to correct number to a certain significant figure in mathematics, then you are going to consider the first non-zero numbers. In that sense, if I'm to correct 1, 2, 3, 4, 5 to 3 significant figure, then I'm going to consider the first 3 non-zero numbers. I hope you understand now. So then the other numbers after the third number, so will be you are going to round them up. What I'm trying to say in essence is that if I have 1, 2, 3, 4, 5, for example, and I want to write this number, I want to correct it to 3 significant figures, then 3 significant figures means the first 3 non-zero number, then that means I'm going to stop here. 1, 2, 3. But before you stop, you have to check the numbers immediately after 3, whether it's going to be rounded up or down. And don't forget, in your approximation and estimation, when you have number from 0 to 4, you are going to round them down to 0, and number from 5 to 9 will be rounded up to 1. You understand now? You will see that this 4 is going to be rounded up to 0. 0 plus 3 will give me 3. Then I'm going to have 1, 2, 3 Then all other numbers after 3 will now be 0. 0, 0. So if you check it now, you will see that this number is what? Is corrected to 3 significant figures. And that's why if you check the first 3 numbers, you find out that they are not, non-zero. Okay, now what about this? You can use the same idea to solve this kind of problem. I have 0.007985. You understand now? They call significant figures are what? First non-zero numbers. It means if you want to start counting now, are you going to start here? No, because this is 0. Recall, significant figures are first non-zero figure. So 3 significant figure means the first 3 non-zero numbers. Then I'm going to start from 7 here because this is the first non-zero numbers. That's the first one, 1, 2, 3. Then I'm going to stop here. Recall, before you stop, you are going to check the number immediately after that third number. In this particular case, the number is what? Is 5. Will 5 be rounded up or down? From here, I said when you have number from 0 to 4, you are going to round it down to 0, but 5 to 9, number between 5 and 9 will be rounded up to 1. Then you are going to round this guy up to 1, then 1 plus 8 will give me 9. Then I'm going to have 0.0079, then 1 plus 8 will give me 9. So then all numbers after 0, after 8 now, after this, you can make them to be 0. But you don't need to stress yourself. So the reason why so there's 0 here. The reason why you don't need to stress yourself by putting 0 here is that 0 at the end of what? Of mantissa. When we say mantissa are like the decimal part. So it's insignificant. So you can just put your answer like this, 0.00799. I hope you understand now. So this is your result. Okay, now can you try one significant figure now? This one, in one significant figure, what is it going to give you? One significant, that is the first non-zero number. You are going to stop here. But before you stop, you check the number immediately after 7, which is 9 here. Will 9 be rounded up or down? 1 will be rounded up to what? To 1. Then 1 plus 7 here will give me what? Will give me 8. Then I'm going to have 0.008. So that is that. And that's why you have to be very careful of, we call something distractor. What did I call it? Distractor. In your exam, in your OBJ question, you'll be having distractor. Distractors are those things that actually look like an answer, but they are not. You understand now? They actually look like an answer, but they are not. In fact, most of the time, they used to put it at the first option so that many students will just quickly go there. I hope you understand now. So anytime you are solving mathematics question or you are doing something that is related to mathematics, so you have to beware of H, you have to beware of distractor. Okay, now next question. If that is cleared, next question. So I think the next question here is on number-based system. Let me just bring it here. So the question asks us to simplify. Oh. So the question asks us to simplify 112 base 2, 11 base 2, everything raised by 2. This is a number-based system. The principle of working a number-based system is different from, your usual whole number. Because when you are working in a number-based system, then you can only have number that are less than the base. Number lesser than the base. For example, if I'm working in base 2, then number in base 2, are composed of number between what? 0 and 1. That is number that are less than 2. You must not have 2 or number greater than 2. I hope you understand now. So if I'm working in base 5, then number in base 5 has residues. What do I call residues? Residues are numbers you can only find in this base, and they are what? 0, 1, 2, 3, 4. I hope you understand now. So I'm going to explain further. It's more like modulo, but it's not different. It's slightly different from modulo arithmetic, although the idea are the same. So, and that's why on no account should you now pronounce this number as 11 base 2. You are wrong. Why? Because we are working in base 2, and don't forget what I said. If you are working in a particular base, then you cannot have the base or number greater than the base. I hope you understand now. You can only have the one lesser than the base. So now we are working in base 2. If you now say 11, is 11 part of the residue of base 2? That is wrong. I hope you understand that. That's why you have to pronounce it one by one. And it is advisable maybe when you are doing theory to write your base in word. Don't write it in number, because if you are having bad handwriting like me now and you write something like this, then the marker can think you write what? 112. I hope you understand that. So then we have 1 base 2 everything square. Remember, square of a number means that number multiplied by itself. So then I'm going to have 1 base 2 multiplied by 1 base 2. So addition, multiplication, division, subtraction in number-based system is the same thing as your usual operation too, your usual operator. You understand now? So, but the difference there is that, or what you have to take into account is when you are adding or subtracting, dividing, multiplying in a particular base, then you must ensure that the number can only be less, what the result you can obtain or what you can have must be part of the residue. You must not have number that is the base or number greater than the base. For example, if peradventure I'm now multiplying and then I have number that is 2, if my result is 2 or number greater than 2, then I have to convert back to base 10. You understand now? So you have to convert it back so that you have your residue. I hope you understand now. So okay, now let us now have 1 base 2, 1 base 2. Okay, let us multiply your usual multiplication. 1 times 1, 1, 1, 1, 1. So and when you add the numbers together, then I'm going to have what? 1 plus 1, 1, 1 plus 1, 2. Can I have 2? Because I'm working in base 2, I must not have 2 or number base greater than 2. Then you have to convert it to base 10. How do you do that? You divide by 2 repeatedly until you have what? Until you have 0. Then you now say how many 2 are you going to see in 2? 1 remainder 0, 2 in 1, 0 remainder 1. Then you now write it backwardly. That is 1, 0. It means 2 in base 10 is 1, 0. Then I'm going to add 0 and keep 1. So then if you keep 1 here, 1 plus 1 again will give you 2, but you must not write 2. If you write 2, that means you are telling us you are no more working in base 2. You understand now? So then 2 again, if you convert it to base 10, will give you 1, 0. I hope you understand now. Then you can conclude adequately that 1 base 2, everything squared is equal to 1, 0, 0, 1 base 2. Let's check if it's part of the option. Yeah, I think option A. Another thing I want to inform you, I want you to take into account here is that if you are working in number base, you don't need to stress yourself. You don't need to stress yourself at all. What you have to do is when you have, if you are adding, you can have 1, 1. You can have 2. Maybe you are when you are operating, you can have 2. 2 in base 10 is 1, 0. You don't need to stress yourself. 3 is what? 1, 1. Okay, even if you have 4, that's 1, 0, 0. So I used to advise my students so that instead of you to just be converting it into base 10, just know that okay, now if I have 2, it's equivalent to 1, 0 in base 10. If I have 3, it is equivalent to what? 1, 1. I hope you understand in base 2, sorry. So if you have 4, it is equivalent to 1, 0, 0 in base 2. I hope you understand that. Then another thing I forgot to mention is that on no account you write a number in a particular base without putting the base on it. For example, now we know that 1, 1 is in base 2. If I make mistake by not putting the base on it, then what implies is that I'm working in what? In a standard base. And what do we call a standard base? A base 10. It means if you are working in any base, you have to put their base. But if you don't put the base, that's translating to the fact that you are working in what? In base 10. That you are working in base 10. Okay, now let us proceed to another question. So to another question in the episode. So I want to do it in such a way that even if you come across the same question, so you are going to solve it yourself. So in essence, I'm not just solving the question, rather I'm giving you hint. So now you can solve it when you come across similar question in future. Look at this question. We have solve 2 raised power root of 2 raised to power root 2s plus 1 is equal to 32. You know, this is an indicial equation. When we say indices, indices is the plural form of index. When I have a raised to power b, so this b is known as your index and your a is the base. The plural form of index is indices. I hope you understand now. So, and when we now have your equation in terms of index, then we call it what? Indicial equation. So now we have to find what? The value of x in this indicial equation. When you have something like this, you can see that this guy is having an index. Then just think of making the other guy, that is the one on your right hand side, to be in index form too, in terms of 2. I hope you understand. Recall 32 is same thing as 2 raised to power 5. If you are keen, into in the indices, you should know that 32 is 2 raised to power 5. You know, there are something that are standard thing you have to actually know in the indices. So then you can write this as 2 raised to power 2s plus 1 is equal to 2 raised to power 5. You understand now? So because we want to find the value of x, then you have to think of all possible ways or all possible means you can do or you can use to get rid of this base, so that you can have way for your what? For your x. By doing that, we see that you can equate the base. From there, I can have 2 root 2s plus 1 is equal to 5. And now we still want to know the value of our s, and this guy, the radical is delaying it. You have to get rid of the radical. How do you get rid of the radical? You square both sides. So square both sides. Then I'm going to have root 2s plus 1, everything raised to power 2, 5 raised to power 2. Then this guy will cancel this. Then you have 2s plus 1 is equal to 25. 2 is equal to 25 minus 1. 2 is equal to 24. And what is such number? You are going to multiply by 2 to give you 24. That is 12. Then your s is 24 divided by 2, which is equal to 12. So, yeah, let's check. Yeah, so the option is what? Option C. So, option C. Okay, now let's proceed. Another one, another question. This one is on logarithm. So, these are the common questions you should be expecting them in your exam. You should be expecting them in your exam. They will actually come out. I can bet you, although I can't bet, but I can bet you that it will come out. You understand now? Look at this. So if log 2 base 10, when we say logarithm, you know, the other time I explained index. You understand now? You know, if I say a raised to power b, I said this is what? This is power and this is base. You understand now? So when we now say logarithm of a number, logarithm is just like a power. We know that if I have 2 raised to power 3, I know 2 raised to power 3 is 8. Then logarithm of 8 to the base of 2 is what? Is 3. That is, what are you going to raise to 2 that will give you 8? So just think of logarithm as what? As what? As power. So, but this kind of question we have that if log 2 base 10 is equal to m, and you have your log 3 base 10 is equal to n. Then find log 24 base 10 in terms of m and n. Log 24 base 10 in terms of m and n. And don't forget we have, different laws of logarithm. So one of them I want you to know is that when you have log mn, so it's the same thing as what? That is the log of the product of two numbers is the same thing as the sum of their logarithms. Log m plus log n. You understand now? So the logarithm of the quotient of two numbers is the same thing as what? Is the same thing as the difference of their logarithm. So these are some of the law you have to take into account. Then when you have log m to a base m, it's the same thing as 1. Then when you have log a raised to power b, then the same thing as b log am. Just put the index here. Then another one I want you to, maybe when you have log a base b, you can actually write it as what? Log a base c divided by log b base c. So we have many of them like this. So, but now look at this. Now you have log 24 base 10. And if you check it very well, we were only given log 2 and log 3. What they are trying to tell you, mathematics is very simple. What they are trying to tell you is that this log 24, write it in such a way that you are going to have 2 and 3. I hope you understand now. And that is true. I can just say log 8 times 3. 8 times 3 is 24. Oh, we have 3 now. Okay, what of 8? I can also say 8 is same thing as 2 raised to power 3 now. Is that not so? 2 raised to power 3, 2 times 2 times 2, that is 8 base 10. Then once you have that, don't forget the logarithm of product of two numbers is the same thing as the sum of their logarithms. Then I can rewrite this based on the law I wrote up. Log 2 raised to power 3 base 10 plus what? Log 3 base 10. And don't forget, one of the law I wrote is that when you have log a raised to power b to base m is the same thing as b log a base m. So it means you can write this guy as 3 log 2 base 10 plus log 3 base 10. Now we have it in terms of what? In terms of 2 and 3. And we were told that your log 2 base 3 is what? What is log 2 base 3? Log 2 base 10, we were told it is m, and log 3 base 10 is n. So then whenever you see log 2 base 10, you put m, then it's going to be 3 times m plus n. Then your answer is 3m plus n. So your answer is 3m plus n. I hope that is clear. You can see it is not difficult to do. Let's see if we have so we have it. We have it. Mathematics is very simple. Mathematics is very simple. Okay, now let's move to the next one. Let us move to the next question. So the next question on the list, that is not difficult to do as well. So we have it as a sequence. So you will have I refer you to my videos on series and sequence. I've done that. So we have to find the fifth term of a sequence. What's the meaning of sequence? Sequence is an arrangement of number in a definite order. You understand now? In the definite order, I mean, maybe that order follows a particular term. I mean, let me say your arrangement follows a particular order. Sorry. You understand now? Take for example now, maybe if I have 4 children and my firstborn age 10 years, my secondborn 8 years, my thirdborn 6 years. You understand? And my fourthborn 4 years. Even if I have 5 children, you should be able to know from that my last born will be 2 years old. I hope you understand, and that's sequence. So when you are arranging numbers in a definite order or pattern, then we have a sequence. I hope you understand now. And we have different type of sequence. We have the commonest one are what? Arithmetic sequence. What is arithmetic sequence? It's also an arrangement. So, but you have the relationship between the two consecutive terms is just different. You understand now? So which we call common difference. In essence, when I have the first term, then the difference between the first and second or third and second will be the same constant term. I hope you understand that, which we call common difference. Then we still call this a linear sequence. An example of that is when I have 2, 4, 6, 8, 10. So you can see it is a linear sequence because the difference between two consecutive, terms here is what? Is 2, and it is constant for all of them. I hope you understand. And this is known as the first term, second term, third term, fourth term, fifth term. So then we still have geometric sequence. What is geometric sequence? Is also known as geometric progression, or so it is also known as geometric progression. I call the arithmetic progression linear sequence. You can call geometric progression exponential sequence. That is a kind of sequence whereby the relationship between two consecutive terms, the subsequent term can be obtained by multiplying the preceding term by the same number. You understand now? Take for example now, if I now have 2, 4, 8, 16, 32. You know, if I want to obtain this now, or I want to obtain subsequent term, it can be obtained by multiplying the preceding term by the same constant number. In this sense, 2. So this is 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. You know, it follows a certain rule that is multiplied by 2. So that is sequence for you. So an addition of sequence is known as series. So when I have 1, 2, 3, 4, this is a sequence. 1 plus 2 plus 3 plus 4, that is known as series. Please refer to my video on sequence and series. So, okay, now we now have 2, 5, 10, 17. So then we have to find the fifth term. Just check the relationship between these terms. You can see that 2 and 5 now, if I were you, first thing to think of is maybe do subtraction first. Subtract the two consecutive terms from each other and see what you are going to have. If it doesn't give you something that makes sense, then you divide. That's one of the hints you can use. So, you know, if I say 5 minus 2 now, that is 3. 10 minus 5, that is 5. It doesn't make sense yet, but see now, you have 5 minus 2, that is 3. 10 minus 5, that is 5. 17 minus 10, that is 7. What do you observe? You observe that the difference between two consecutive terms are what? Are consecutive odd numbers. In essence, it means for me to obtain the next one here, I'm going to add the next what? I'm going to add the next odd number. I'm going to add the next odd number. So if you are now add the next odd number, what are you going to have? What are you going to have? Yeah. So that will give me what? You know, the next odd number here is 9. So then 9 plus 17, that will give me 26. You understand that? That's the fifth time. If I want to obtain another one, I had 11. That will give me 37. If I want to obtain another one, I had 13. So you just take note of the rule, and that's it. And another sequence I think I want to inform you is known as what? Fibonacci sequence. What is Fibonacci sequence? So that is when I have 0 here, 1. That is the sum of two previous terms will give you the what? The next term. Then 0 plus 1 will give me 1. If I want to obtain the next term, it will be 1 plus 1, that is 2. 1 plus 2, that is 3. 3 plus 2, that is 5. So that is known as what? That is known as Fibonacci sequence, and so on and so forth. Okay, now the next question. The next question. So yeah. Okay, now this question, I think it is a set. And you know, if you watch my video on set, you will see that there are different ways you can write set. In essence, you can write set in using Venn diagram or using set builder notation. And I think this question is about it. Set builder notation. You know, we have that if my P and Q is that, where S is a real number, you know real number, that is a number, it can be natural number, it can be an integer, it can be real, it can be rational, even it can be an irrational number. You understand now? So if I were you, since this set builder notation, you have to write your P first. So for your P, you were given that it is S, such that S is what? S is greater than minus 3 but less than 1. If S is greater than minus 3, then your S will start from minus 2. Don't forget this is your number line. And when we say something is greater, you know, this is 0, 1, -1, -2, -3. 1, 2, 3. For those of you following my engineering mathematics class, you know I told you when we say something is a number is greater, maybe S is greater than the number. That is, that number will be at the right hand part of your number line. So if I say S is greater than -3 now, then it will be here, right hand part of what? Of the natural number. That will start from -2, -1, 0, but less than 1. It means you have to start at 0. You have to stop at 0 because this number is not equal to 1. At the beginning, they say less or equal to 1, you can write 1, but they say less than 1. That is not up to 1. Okay, now likewise Q, you have that your S is greater than -1. In mathematics, you don't say -1 less than S. No, you have to say it correctly. Say it like a mathematician. S greater than -1 less than 3. That is, S must not start from -1, but it must start from what? From 0. Then you have 0, 1, 2. Will you have 3? You cannot have 3. I hope you understand now. So, and the question asks us to find what? P intersection Q. What is P intersection Q? Intersection of a number means element, the common element in that set. So the P intersection Q is the common element in P and Q. And what's the common element in P and Q? 0 is here, 0 is here. Then your common element will be 0. Are you getting that now? So common element will be 0. So this is your answer. What can you say about 0 now? 0 is called a singleton set. What do we call singleton set? That is a set having just one element. Don't confuse this guy as what? As empty set. Oh. You know, some people might say, oh, it is having 0. It is an empty set. No, it is not an empty set. An empty set can only be written either using your braces or you write phi. That is an element having no element in it at all. But this one is having an element 0, so which is known as what? A singleton set. So which is known as a singleton set. Okay, now let us do another one. So look at this question. So I have, and this is on factorization. This is on factorization. Okay, we have to factorize 6pq minus 3rs minus ps plus qr. You understand now? So yeah, what we can do now is that the one that have common factor, you can marry them together. For example, now you can see that this guy and this guy have common factor. Maybe if I write 6pq plus 6qr minus 3rs minus 3ps. Then you factor out the common factor. What do you have in common? For example, now you have p to be common here. You understand? 6p, sorry. Then this one will be what? Q. Oh no, 6q, sorry. Then this one will be p. When you factor out a number, it means you have to divide it by each of the term. So since I have factored 6q out, then what will be left here is p. How do I know it is p? I divided 6pq by 6q. I hope you understand now. 6pq by what? 6q, and this guy will cancel this guy. You have p left. Then plus r. What do you still have left here? I think minus 3 is common. S is also common. So if you still factor it out, what do you have left? This is also what? I'm going to have r here, then plus p. R plus p. And don't forget, even this one, you can rewrite it as r plus p since addition is commutative. When we say something is commutative, at this one you have an operation star such that a star b is also the same thing as b star a. And addition is commutative because 2 plus 3 is also 3 plus 2, which both of them are 5. Then minus 3s r plus q, r plus p, and r plus p is common. What do you have left here? Then I have what? 6q minus 3s. But there is another common factor. Even if you check here, you still see that 3 is common. If I factor 3 out, then this is going to be 2q minus s. Then this is something as 3r plus p, 2q minus s. R plus p, 2q minus s. So yeah, I think there is I think the one that is very close to that result. Check here. I hope we've not made any mistake. Since I factor negative here, the hand is showing. Okay, check it. Yeah. Okay. I don't make a mistake. 6q minus 3x. Then 3 is common, 2q minus s. Let's check it again. 3 p plus r, 2q minus s. I think they made a mistake here. Maybe this one is not there. So yeah, that is that. It might be a typo, when we were typing the question maybe. So let's move to the another question. Look at this. It's not difficult to do as well. So we have that. Okay. So we have that what number should be subtracted from the sum of what? What number should be subtracted from the sum of 2 whole number 1 over 6 and 2 whole number 7 over 12 to give 3 whole number 1 over 4. Let the number be x. If the number is x, that is from the sum of these two guys, 2 whole number 1 over 6 plus 2 whole number 7 over 12 minus x to give this 3 whole number 1 over 4. If I were you, I can convert this back to improper fraction, or you can do it straight away like that. You understand now? If you are sure you are not going to make a mistake. So if you are sure you are not going to make a mistake. So this is 13 divided by 6 plus 24, that is 31 divided by 12. So then you have minus x is equal to 13 divided by 4. Your LCM is 12. This will be 26. 6 here. 6, that's 2 times 13, that's 26 plus 31 minus x is equal to 13 over 4. You understand now? So, and this one will give me 57 divided by 12 minus x is equal to 13 over 4. So if you collect your like times, then your x will now be what? 57 over 12 minus 13 over 4. And your x here will be 12. This is 57 minus 3. 3 times 13, that is 39. So, and that will give you, I think, that is 18, right? 18 divided by 12. Am I correct? Yeah. And what is 18 divided by 12? That's the same thing as 9 over 6 because we will divide by 2. It's an equivalent fraction to 9 over 6. Even 3 can still go. 3 here, 3, 3 here, 2. Then your answer will be what? One whole number 1 over 2. So I think it is there. So it is there. Option there is what? Is one whole number 1 over 2. Look at this question again. Look at this question. So I have that if Mensa is 5 years old and Joyce is thrice as old as Mensa, if Mensa is 5 years old, I think after this question, maybe for each of the episode, I should be solving 10 questions so that it will not be too much. Because even myself, I find things boring if they are too much. You understand? So, yeah. So, Mensa is 5 years old. Mensa is what? 5 years old. And what? Joyce is thrice as old as Mensa. Thrice means 3 times of Mensa, which is 15. So, in how many years will Joyce be what? Twice as old as Mensa. Joyce, in how many years? Let's say we don't know that years. Maybe the year is X. You understand now? It means then the new age of Mensa will be what? That is 5 plus X. And the new age of Joyce is what? That's what? 15 plus X. Then in how many years will Joyce be? Where is Joyce now? That's 15 plus S is as twice as old as what? Mensa. Twice means 2 times. That's 5 plus X. So if you solve it, then 15 plus X is equal to 10 plus 2X. You understand now? If you collect the like time, this guy will give me what? So you bring this guy here. That is 15 minus 10 is equal to 2x minus x. That is 5 is equal to s. So x is equal to 5. That is in 5 years' time. So in 5 years' time, that is that. So it is not difficult to do. I think one of the problem is just to translate it. Maybe you have to say it in your language so that you get it clearly. I think another question, which is number 10 here. So we have 16 multiplied by, maybe I should just write it. 16 multiplied by, let me change my pen. 16 dot 2x plus 1 is equal to 4 raised to power x multiplied by, that is dot 8 into 1 minus s. Then we have to find x. And our option are Option 1, we have minus 4, 4, minus 1, 1. This is not difficult to do. This is also an indices, like I've said the other time, indicial equation. You know, you have 16.2x plus 1 is equal to 4 raised by x dot 8 minus x, right? Then I can rewrite this. This is the same thing as 2 raised power 4 multiplied by 2x plus 1. Then this is also the same thing as 2 raised power 2. 4 is the same thing as 2 raised power 2. Just ensure they are having the same base. Then multiply by 8 here, that's 2 raised power 3, everything raised by 1 over x. And this one will now be done. If you apply your laws of indices now, when you have the same base and you have multiplication as their relationship, so then you have to add the index. Then you have 2, 4 plus s plus 1 is equal to, a raised power m, everything raised power n is equal to amn. Maybe I should write for you some of the laws of indices. You have a raised power m multiplied by a raised power n is the same thing as a raised power n plus n. A raised power m divided by a raised power n is the same thing as what? A raised power n minus n. A raised power m, everything raised power n is equal to a raised power mn. Then when you have power 0, then it is 1. N number raised power 0 with an exception of 0 is 1. Although some textbooks say even 0 is there. But generally speaking, 0 is not there. Then power unity, a raised power 1 is a. How many rule like that? So, but the one I want to use here is this guy, AMN. It means this is going to be 2 raised power 2x times 2 raised power 3 minus 3x. Okay, now if you still apply laws of indices, this will be 4 plus 1, that's 5 plus x equal to 2 raised power 2x plus 3 minus 3x. If you proceed, that's going to give me what? 2 raised power 5 plus s is equal to 2 raised power minus s plus 3. You understand now? And you can equate this base. Then you have 5 plus s is equal to minus s plus 3. Then you collect the lifetime. This will be s plus s equal to 3 minus 5. That's 2s equal to minus 2. S will now be minus 2 divided by minus 2, which is equal to minus 1. Yeah, so I think I'm going to stop here. In the next episode, I'm going to continue from where we stop. If you are really keen about having distinction in your mathematics, then you have come to the right place. Why not like the video, subscribe so that you see the subsequent videos, and share with your colleagues so that they can benefit too. Till I meet you in the next video, thank you very much.